Hello, I'm Beesung from Busan National University. I'm here to talk about generation of author output based on iterative clustering method. When a researcher wants to have a background or related works, he needs to have a related content, and to get those content he needs to search author's name on databases, and by searching author name in database, results are not much welcome. Ambiguous names is the most challenging issue for a researcher. There are many articles address these challenges. Fixing ambiguity of names used by researchers in database. Even though there are many articles describing how disambiguity of authors can be reduced, I gathered 5 recent articles to address this issue with new technology. One of them is using machine learning to assist indexing for search. This article, presented in Data and Info Journal in 2018, provided by Dr. Cohen, is a guideline to use metadata for searchings. These metadata includes author first name, initial, middle initial, and author's email, ORC identifier, and others. ORC identifier is a unique name assigned to authors, and by searching these identifier, disambiguity of authors can be reduced. This article uses PubMed article and have 1000 training set to be compared with searching names. This article is only a guideline. They didn't provide any data. The method is interesting, but as you can see, ORCID identifier used for international publications, and most national publications, they don't have an ORC identifier. Another article is talk about bibliographic database, which uses national database. This article provided in 2018 by Linda Seil, and it published in Research Education Journal. This article is talk about how comprehensive is national bibliographic database. In order to do so, they had 20 national databases with 13 database sets. Some nationals shared some databases, so the number of national is more than database set. Later, they end up with diverse content and similar content with different purpose, because each national uses different purpose of content to their database. In their searching methodology, they use title, year, and author name. Limitation of this work was when they were setting database. Because of the language barrier, they had difficulty setting up the database because they didn't have a unique manual. And the other problem was their national databases were changing rapidly because of adding authors, deleting authors, or adding new content. Another article is talk about authors' disambiguation, published in Scientometric by Mark Muller in 2017. As you see in the image, that they provide names, same names, but use different character for visualization. This is an interesting article because in their metadata they had visual virtual name that user could see, and in the background they use their own metadata by adding exact name. So by searching those exact names, the author could be described more accurate. They use title, year, and author name for searching methodology, and their result was 77 to 100% accuracy of searching same names in the database. They use KISTI dataset for their methodology. Another interesting article is also talk about disambiguation using machine learning in 2018 by Kim Jin-seok and Kim Jin-mo. You see the first initials are same, but they are different persons, different names. This article published in Scientometrics, and they used computer science bibliography dataset. They had 3 filters. As you see in the image, it's a positive curve and with negative curves. And when we mix positive training and negative training, we have overlap line, and if the distance of overlap line is less than the disambiguity of the name is less too. But in another example, when we have a positive training and negative training and we mix them together and we have a distance line between overlap lines, then the names are disambiguate. In their searching methodology, they use title, year, author name, and author venue. This article describes that by adding positive and negative training to a dataset, disambiguate name can be figured out. This article, presented by previous author Jin-seok Kim and Jin-mo Kim and others, presented in 2019, published in Scientometric Journal. This article talks about how to solve disambiguation use iterative clustering method. Interesting part about this article is their accuracy is over 97%. This article solves 3 problems of their previous work, which was when the first initial name is different, machine learning cannot detect those names, and the positive and negative curves are misleading. Their second problem was if the author and the co-author has a different level of scientific background, then the machine learning is also mislead. Their third problem to tackle was if they have known matching results, those would not be considered negative training. So they fixed these 3 problems in their new article, and their result was if they use full name and email address, their accuracy gets over 99%, which was pretty impressive and high. This article used searching methodology of title, ORCID, DOI, author name, and email address. The challenges that we are facing here is these articles are used in international database, but national databases mostly they don't use ORCID. They have DOI, and some nationals they even don't have a unique identifier for authors. In Korea, I have seen that databases such as RIS or KMBase or DBPIA, they don't have an email address in their content, in their metadata. And the third problem was author name ambiguity is much more in Korea than other places because the first initials are same for many people. Enrollment of method of this article was to use 2 sets, one random and one non-random authors. Non-random authors were picked among those authors that have frequent published articles, and we used international output and national output both together because the 3 databases we use, KBase, RIS, and DBPIA, they had international and national outputs mixed together. Not all, but some of them. And then we compared names with the dataset. We had total of 759 confirmed publications. Our result for national articles were 93% in random authors and 87% accuracy in non-random authors. This is only national articles, and we didn't include international articles because that is the limitation of our work. Because we used 3 national databases, our international articles were not included in those 3 datasets. So missing articles was our limitation of this work. We believe if we add more databases to our method, we can improve the result in our next work. In the graph, you can see the difference between finding articles and existing confirmed articles are much more higher than national articles. We hope to address this issue in our next article. Our national output shows much more better results. You see overlapping lines between finding articles and existing confirmed articles are less and less. This is not as high as 99% of our related work, but it shows around overlapping lines between finding articles and existing confirmed articles. Thank you for watching this video.